All right, so here we're going to talk about the future value of an annuity, or also known as a sinking fund. We're also going to look at that. So an annuity is any sequence of equal periodic payments. The future value of an annuity is the sum of all the payments plus all the interest earned. So how much will it be worth in the future? A sinking fund is any account that is established for accumulating funds to meet future obligations or debts. In a future value of an ordinary annuity, FV would be the amount in the account, that's the future value. PMT is going to be the periodic payment. I will be the rate per period. N is the number of payments. And you have a whole bunch of stuff going on. Now we already have some other letters that we know. R over M is equal to I, and that's going to be your rate divided by the number of compounding periods. All right, so for example 1, we're going to find I and N for the annuity with monthly deposits of $425 are made for 8 years into an annuity that pays 9.5% compounded monthly. So we're looking to find I and N. So I is going to be equal to our R over M, and N is going to be equal to our MT. All right, so this is 3.3, and we're on example 1. I equals R over M, and N will be equal to M divided by T. So the rate that we were given was 9.5%. Again, has to be written as a decimal. And we were told that it's compounded monthly, and monthly is going to be 12. We'll put that in the calculator and get 0.0079. The M is still monthly. Oops, and I wrote M divided by T. It's M times T. Sorry about that. I'll just rewrite it. So N equals M times T. M is still 12, and T, we were told that it was for 8 years. We're going to multiply by 8 and get 96. So those are your 2 answers for number 1. All right, so for number 2, we're going to find the future value. Given N equals 19, I equals 0.06, and the payment is equal to $250. And we're going to do to the nearest dollar. So pay attention in your homework if they're asking for the decimal places or to the nearest dollar. So for this, we have payment, PMT, I, and N. So future value equals this formula here is the one we're going to use. There are a lot of formulas in these sections. You will have all formulas provided to you for the exam because there are a lot of them. And then it's all over I. All right, so let's plug in our values. I'll just go ahead and put it down here. So future value will be 250 times 1 plus our I is 0.06, so 0.06, raised to the N of 19, and then minus 1 divided by our I of 0.06. Now, on the formula, that's how it looks. I'm going to tell you that we're going to need to put in brackets here, and I'm also going to put in a set of parentheses here because you have to get the entire top part together. If you just put this in, minus 1 divide by that, it'll divide negative 1 by 0.06, which is not the same. The other thing I'm going to tell you to do is find this section with the brackets first and then multiply by 250. Typically, when we're in class, face-to-face, my students will multiply by the 250 first, and then it just doesn't seem to work out. They get something not quite right. So if you do this first and then multiply by the 250, it's the same information being put in, but it seems to go better. All right, so I'm going to show you how to put this in. So first thing, we don't need to do the brackets. We're just going to do the top and the bottom. So I have 2 parentheses, so 2 parentheses. 1 plus 0.06, close the parenthesis, whoops, got to erase it, to the 19, then back it back down, minus 1, close that first top parenthesis. So that's all of my top. Now I'm going to divide by 0.06 and hit enter. So now I have 250 times, and I'm going to write this number so you can see, we have 33.7599917. So I've multiplied that part there. So that's, and now we'll just take that, we'll just hit times 250 and hit enter again. Now we're going to round this to the nearest dollar. The 7 will cause the 9 to round up. It's going to be 8,440. And even if they didn't round, if you were at 99 cents, nearest dollar is going to be $40. So we're going to be at 8,440. Okay, so that is example 2. For example 3, we are going to find the payment. So find PMT given that the future value equals 4109, N equals 32, and I equals 0.035. So again, we're going to pick our formula. We're given I and N, so we're going to use our payment equals this one here. So our payment equals the future value, I, divided by 1 plus I to the N minus 1. Now the future value is at the top, but you can also just multiply it off to the side because sometimes it gets a little bit easier, again, to do that first. All right, so our payment is going to be 4109, and then at the top, we're going to have 0.035 divided by 1 plus 0.035 raised to the n of 32 minus 1. All right, so let's talk about this one the same way. We're going to have parentheses for the entire bottom, and then again, we're going to have parentheses that do the whole deal. And we're going to do this first. So let's go get our calculator again. We're going to have our 0.035 divide by 2 parentheses, 1 plus 0.035, close the parenthesis, raise to the 32, back it back down, minus 1, close the parenthesis. And we should get 0.017441505. Let me write that down. So we have our 4109 still, and 0.017441505 is in my calculator. Right now, I will take that and do times 4109, and I'm going to get 71.667. It didn't tell me to round to the nearest dollar, so I'm going to go to 2 decimal places. The 7 causes the 6 to go up. So we'll get 71.67. Okay. So doing that part first can sometimes help. All right, let's go on to example 4. So for example 4, we are on our handout. We've got another word problem. So recently, More Money for You offered an annuity that pays 7.5% compounded monthly. If $250 is deposited into this annuity every month, how much is in the account after 15 years? How much is in interest? Round to the nearest dollar. All right, so we are looking for how much is in the account after 15 years. That's future value. And then we're also going to find out how much interest, and they're telling us to round to the nearest dollar. So what all do we have? What has been given to us? We have 7.5% compounded monthly. That means I need a formula with an M. And then we have a payment, and we have a time. So let's go look at our formulas here. I need one with an R and an M and a payment. So a future value, we're going to use this formula here. So this is example 4. We're going to have future value equals payment times 1 plus R over M raised to the MT minus 1 over R divided by M. All right, so our future value will be equal to our payment. Our payment is $250. And then we have 1 plus, our rate was 7.5%. So again, as a decimal, 0.075, divided by monthly, which is 12, raised to the monthly times 15 years, minus 1, divided by that R over M. All right, so now let's go put our parentheses in again. So we're going to have parentheses at the top, parentheses at the bottom, and then we're going to do our big brackets again. So again, we're going to do this part first. So we're going to do 2 parentheses, 1 plus 0.075 divide by 12. Again, I don't put in a fraction. I just put divided by 12. The calculator knows PEMDAS. Raised to the 12 times 15. You can multiply that first if you want to. And then back it back down, minus 1, close the top. So now I've got that parenthesis closed. Now I'm going to divide and then open the parenthesis, 0.075 divide by 12. You don't have to put the 0 before the decimal place. I just tend to, so that it's very clear to my students that it's 0 point. And then I'm going to hit enter. All right, so I'm going to write that number down so that as you're working it, you know if you got the right number. 250, and then we have 331.1122763. Notice I never round that number. I just take that and I multiply by the 250. We need to go to the nearest dollar again. So it's 0.06. So we're just going to leave it at 8 for the dollars. We're not going to round up to 9. So this will equal 82,778. That is the amount in the account. All right, now the other part of the question said to find out how much interest did we earn. All right, so to find the interest, let's switch pens here. Our interest will be equal to the amount in the account minus the total payments. When we did some previous problems and we found the interest, we just subtracted out the principal because that was the amount we put in the account. But with these, we're actually making payments. We got to go find the total payments. So for the total payments, we made payments of $250. We did them monthly, so that's times 12, and we did them for 15 years. And that will get us $45,000 is what the total payments we put into our account. So we're going to have the amount in the account, $82,778, minus the $45,000 that we put in over the 15 years, will tell us that we earned $37,778. That is how much interest we earned. So it's a little bit different than some of the others because we're making payments. We're not putting in just an amount. All right, let's go look at number 5. In order to accumulate enough money for a down payment on a house, a couple deposits $1,389 a month into an account paying 8% compounded monthly. If payments are made at the end of each period, how much money will be in the account in 8 years? Round to the nearest dollar. All right, so we are looking for how much will be in the account in 8 years, so that tells us it's a future value payment. And we are told it's compounded monthly, so we know it's going to be the one with the M. All right, so this will be example 5. So we're going to use future value equals the payment times 1 plus R over N raised up over M raised to the MT minus 1 divided by R over M. So it's very similar to the last problem. All right, so our future value will be equal to our payment of $1,389 times 1 plus our interest rate was 8%, 0.08, compounded monthly, which is 12, raised to the 12 times 8 years. And then minus 1 divided by our R over our M, so 0.08 divided by 12. I'm going to go back and put in my extra parentheses. I have the whole top divided by the whole bottom, and then that will be all multiplied by our payment. All right, so let's go find those numbers again. So let's do it again. So we've got 2 parentheses, 1 plus 0.08 divided by 12, close the first parenthesis, raise it to 12 times 8, back it down, minus 1, close the parenthesis, divided by, open parenthesis, 0.08, divide by 12, close the parenthesis, and we get 133.865, or 868583. So now we have 1389. We're going to multiply that by the 133.868583. So we'll take our calculator and just hit times 1389, and that'll get us 185,940. Now we only have 46 cents. That's less than 50 cents. So it will not round up, so 43. So they got quite a bit in their account to put a down payment on a house. They have $185,943. All right, our next problem is again on our handout. Number 6, Acme Annuities recently offered an annuity that pays 3.3% compounded monthly. What equal monthly deposit should be made into this annuity in order to have $500,000 in 40 years? Equal monthly deposit, that means the same thing as the payment. What payment should be made into that annuity to have $500,000 in 40 years? All right, so we are given, for this one, we have compounded monthly again, so we're going to be using the second part of the formula because we have an M. So this is example 6, all right, yes. So we're using the payment equals to, to not a p, but future value, times our r over m divided by 1 plus r over m raised to the mt minus 1. All right, so we got to make sure that we put in our values right. So our payment is going to be equal to our future value. We want $500,000 into the account. We have 0.033 as our interest because it's 3.3%. And it was compounded monthly, so divide by 12. Divided by 1 plus our 0.033, divide by 12, raised to the m times t, so 12 times 40 minus 1. All right, so we got to have parentheses on the top, parentheses on the bottom, and then a bracket. And I do these in red just so you know for sure. You must have these, otherwise it's not going to come out to the right answer. All right, so let's put this in our calculator. We're going to get, let's clear the old problem, so we'll have parentheses, 0.33, whoops, forgot my 0, make sure you don't forget that, 0.33, divide by 12, close the parenthesis, divide by 2 open parentheses, 1 plus 0.033, divide by 12, raised to the 12 times 40, back it down, minus 1, close the top of that last parenthesis and hit enter. And we should get a really long decimal. So now we have 500,000 times our 0.00100488. Now, when you're doing these like on a test or something, you don't need to show me this number. You just need to multiply by 500,000. I'm writing this out for you so that you're checking with your calculator to see if you have the same one. All right, now I'm just going to hit times 500,000. So make sure you have enough zeros. There should be 5 of them. Hit enter. 502.439. That 9 is going to cause the 3 to round up. So it will be 502.44. So what we have to do is deposit into our account $502.44 every month in order to have $500,000 during that time of 40 years. All right, let's go look at example 7. Bob makes his first $2,500 deposit into an IRA, earning 6.4% compounded annually on his 23rd birthday, and his last $2,500 on his 48th birthday. That means he made 26 equal deposits in all, because he made one on the 23rd birthday and one on the 48th. So you got to count that. You're like, but 48 minus 23, that's only 25. But he also made a payment on that, so you have to count all 26 payments. With no additional deposits, the money in the IRA continues to earn 6.4% compounded annually until Bob retires on his 64th birthday. How much is in the IRA when Bob retires? So this is a two-part problem because we're going to do the future value and then it's going to continue to compound annually until he retires. So let's go look at what Bob's going to have. This will be example 7, last one for this section. So future value, we are compounding annually. So that means we're going to have an M. The M will be 1, but it's still compounded annually, so it changes which formula we're going to use. So we have future value equals our payment times 1 plus R over M raised to the MT minus 1 divided by R over M. So the future value, our payment that Bob made was $2,500. He only made it once a year. So he's got 1 plus, the interest rate was 0.064, divided by M. It was annually, so it's 1, raised to the 1 times RT minus 1, divided by 0.064 divided by 1. You're like, do I have to write the ones? If you're on a test, you would need to write the ones so I can see that you understood it was annually. But let's simplify this down. And I'm going to go ahead and put that set of parentheses so it's not quite floating there. All right, so we got 2,500 times 1 plus 0.064 raised to the 26 minus 1 over 0.064. We don't need to put the ones in the calculator. So we still have to do the top, and then we still have to do the whole thing. All right, so let's go put this in the calculator. So we've got parenthesis, 1 plus 0.064, close the parenthesis, raised to the 26, back it down, minus 1, close the top. Divide by 0.064. I don't have to do parentheses because it's just one number. Hit enter, and this will get us 2,500 times 62.77252512. So we'll times that by 2,500, and that will get us 156,931.31 because the 2 will not cause the 1 to round up. So 156,931.31. So that's how much is in the account after 26 years. But again, he's not pulling the money out. So let's read it again. With no additional deposits, the money in the IRA continues to earn that 6.4% compounded annually until he retires on his 64th birthday. So he's not putting any more money in, but he's not taking the money out. So how much will be in the account if he just leaves that $156,000, almost $157,000, in the account? So now we're going to do compound interest for the rest of the time. So this will be like the second part. So first we got to know how much time. Now he has 64 years minus he's at 48 years. We'll leave 16 more years it sits there. And you're like, but last time we added 1 because we ended up with 26 payments. But there's a difference between 26 yearly payments and then 25 years. There was a payment made on each year, so that makes a difference. So for 16 years, so let's go find out how much is in his account. So here we're going to use A equals P times 1 plus R over M raised to the MT because that's our accumulated value, and it's we have the M, which is annually, is going to be 1. All right, so in the account, we're starting with our principal of $156,931.31. And it's going to have 1 plus 0.064, because it's the same interest rate, divide by M equal to 1, raises to M equal to 1 times 16 years. All right, now what we can do is simplify this. We don't need those ones. So 156,931.31 times 1 plus 0.064 raised to the 16. All right, let's go put this in our account. So we have 15,691.31. Now, I did not use the previous amount because it hadn't been rounded. I want to make sure I round that to the 31 and not leave the extra things. And then I'm going to put in my 1 plus 0.064 and then raise it to the 16. And I get $423,424 It'll be 17 cents because the 2 behind the 7 will not cause it to round. So 423,424.17. So this is the amount in the account when he retires. So this is the amount when Bob retires. So he kept putting in $2,500 a year, and he did that for 26 years. It got to this amount. Even though he didn't put more money in, because this is being compounded annually for 16 more years, it gains a lot of money in there. So again, time is on your side if you're wanting to invest money.